Hello everyone, today we'll see about multi-edge computing or MEC. MEC provides edge computing for many kinds of devices like smartphones, cars and IoT devices, IoT sensors, etc. So what is edge computing? In cloud computing, the remote computing for a device is done in the cloud over the internet, and the services or results are provided from the cloud. Now this is not enough for some applications that have low latency and higher bandwidth requirements. To name some examples are augmented reality and virtual reality. These need lower latency responses from the servers, and the delay from the cloud to the device is not uh, minimum enough for serving these applications. That's why we need edge applications. Sorry, edge servers. So what the edge servers does is that they are close to the end users, so they can provide services with low delay. So they can meet the requirements for augmented reality and virtual reality applications. Besides, edge computing can also provide other kinds of services like uh, local services of a location, content caching for uh, minimizing network bandwidth, etc. etc. So we can say that edge computing is an evolution of the previous cloud computing. Now, where did the edge computing originated from? When 3G was introduced, it was felt that maybe we need content delivery networks just for network operators, and this idea later developed into edge computing. Currently, edge computing or MEC, multi-edge computing, is developed by HC Industrial Specification Group. Now we will see how where are edges deployed. Now HC suggests that MEC platforms are deployed either at the base station or in the S1 interface between base station and core network. Now the interface between base station and core network is GTP based. What this means is that the packets sent from base station to the core are encapsulated with a GTP header. So the GTP headers are set by the base station and read by the core network, which cannot be changed. So when MEC platforms are deployed between the base station and core network, they need to first decapsulate the GTP packets, then they do the necessary processing and then re-encapsulate the GTP packets. This was one challenge for deployment of MEC. Here we can see the reference architecture for MEC. It's a bit tedious, but let me explain. An MEC platform here and the MEC host here represents the single MEC platform we saw in the previous slide. So a MEC host consists of a MEC platform and virtualization infrastructure and some MEC applications. So MEC platform does the necessary functionalities for running MEC applications, and MEC platform also provides some context aware data to the MEC apps like radio network information, location information, etc. The MEC host and the virtualization infrastructure provides the necessary infrastructure like storage and computation to run the MEC applications. Now, the MEC platform is managed by the MEC platform manager, and the edge orchestrator is the system level management node that knows about all the MEC platforms and determines their coordination and deployment of applications in MEC platforms. Thus, it provides the management level of MEC. So this was MEC reference architecture. Let's now see two use cases of MEC. This is the first use case. So use case means where can we deploy the MEC. So this is an example of Riyadh Golf on 2018. So with the help of edge computing, the local videos generated in the stadium was served from the local MEC server. Thus, the network bandwidth means from the core network and the backhaul network bandwidth was not needed. Just the video served from the local MEC server. So the core network was saved. And this is the second use case. This is for autonomous vehicles. The vehicles send and receive data from the MEC and they can drive autonomously. So that's all guys. Thank you.